observations about what happens between two pieces of metal. This is metal and that one's metal. I'll just tink them against one another so I can convince you that they're metal, and you see that they're all shiny, okay? And you'll also notice, I doubt that this will come out, oh no, maybe, that they're emblazoned with N's and S's on the two sides. So that would say these are maybe somewhat special pieces of metal. By touching them to each other, what I have done is to ensure that I don't have any different charge on one than I would have on the other, right? So these are not charged with respect to one another. They might have electric charge, but they have the same charge because I touched these two pieces of metal to one another. And if they had the same charge, then we would see that they repel one another. So I could take this piece of metal, put it over here, and you can see that I actually am able to repel one piece of metal with the other. So great, just like electricity. But then we have an additional observation, which all of you have made. Actually, the fact that you're here at RPI means that most likely you were a nerd and are a nerd. And so you have played with magnets. So now I play with the other side of this magnet and bring the magnet, oops. Oh yes, that's what it was supposed to do. I assert. I bring the other side of the magnet here. So over here, I repelled, these two bars repelled one another. And over here, they attracted one another. Okay? So there is a force acting at a distance in this particular case. Now I can look at the other side of this magnet now and notice that over here they attract one another now, and on the other side they'll repel one another. So I've got a set of observations where one end of an object repels and the other end of the object attracts to a particular end of the other object, and vice versa, okay? So I've already got something that's a little bit more complex than the electric field and electric charge. Then we have another observation. I can take that same material and make it into tiny flakes, and I can take that same material and make it into a bar. So under here, what I've got is a single bar. Yeah, I think we can still see it even though everything's up at once. A single bar in there. Actually, I will mute it. There we go. These two things over here are just pieces of metal that I found in a box to hold up a little plexiglass container here. And now I've got a jar full of iron filings. So the material that was first found to have those kinds of properties was later found to have iron in it. And so what I can do is sprinkle these filings on here. And we see that right away a pattern forms in those filings. That's an indication that there's something going on there with respect to a field, some sort of field, that has a pattern that looks something like that. So I've got a pattern here. I've got attractive force and repulsive force over there. The pattern seems to be a bunch of lines that comes out one side and goes in the other side of this object, right? I can ask, well, what happens if I've got lines going out this end and lines going in that end, let's say? And what happens if I were to cut this short? This is a piece of metal and I'm very strong. This is a piece of metal, but I'm very strong. Let me put that back again. That magnet happened to be one that we broke accidentally, dropped on the floor. But now I've got a third of a magnet, and we can say Does it behave like a third of a magnet? Is this just a plus pole or what? And you should see here that we end up with the same pattern. Lines going out each of the two ends, right? So we've got this field that exerts forces on particles. We can observe the forces in action as I move the magnet with respect to the field. Is going to reorient all of those things. And then we can make some further observations as well. I mentioned that if we have two magnets or two of these objects, then they point with respect to one another. Here I've got a little magnet. This is one of the first really useful tools in navigation. I've got a little magnet here on a pivot, like the pivot that I had over there. And what we can do is look to see what's happening to the direction of the field. You see, as I move like so, the direction of the field switches. So that means that I could describe this in terms of a field pointing in one direction out one end of this magnet. Now I'm already calling it a magnet. And a field pointing in the other direction out the other end of the magnet. So I can think here of a magnetic field that's going to act on other magnets that looks something like this. In, out. That's the pattern as I saw it.